Welcome to a video tutorial on how to understand evolutionary trees. An evolutionary tree is called a phylogeny. Phylogenies show paths of evolution and relatedness of species, which makes them helpful because they allow us to understand evolution on a larger scale. This is the anatomy of a phylogeny. The root is at the very bottom, and this is where the rest of the tree stems from. The root is the common ancestor of all organisms present in the tree. The internal nodes represent other common ancestors present in the tree. Nodes also indicate diversification of species. In this tree, the heart and the circle both share two common ancestors in addition to the root. The terminal nodes, or the tips, represent current organisms. Although they may not seem related, they show relationships between species that you may not have even thought of. A branch is also part of an evolutionary tree. These groups are sister taxa. They come from the same direct common ancestor. The in-group shows the species with common characteristics relevant to this specific tree. The outgroup is a species that is included in the phylogeny, but does not fit in well with the tree-specific classification. However, they are all related. Note that the outgroup does not have any branching occurring. This does not mean that the outgroup doesn't undergo any evolutionary change. Branching is just not shown in the outgroup because the outgroup itself does not fit in with the common characteristics of the tree as a whole. In this way, the outgroup acts as a reminder to biologists of the grand scheme of evolution and that species that may not look similar can still be related. It's important to note that trees can be represented in many ways. However, they still tell us the same information. Remember, the direction of the branch is irrelevant, but rather the topology or the order of the branches occurring is what matters. Nodes can be rotated, so the order of the tips can be changed. Do not read across the tips. Moving on to cladistics. Cladistics is a term used for classifying organisms based on evolutionary relatedness or shared characteristics. In a cladogram, the branch lengths are not significant. Only the topology, the order of branching, matters. In a phylogram, the branch lengths are significant. They show the time or quantity of divergence. Within an evolutionary tree, there are different groups. This is a monophyletic group. It can also be called a clade. Monophyletic groups and clades show the common ancestor in all of their descendants. As a helpful tip, to find the number of clades, count the number of nodes. Remember, each node and their root are a common ancestor, so the number of nodes is equal to the number of clades. This is a paraphyletic group. The recent common ancestor is shown, but not all descendants are included. This is a polyphyletic group. The recent common ancestor is not included, but distant relatives are included. A tree that looks like this is called a soft polytomy. Soft polytomy indicates that the pattern of branching is unknown, so this is an evolutionary relationship that is not fully understood. Congratulations! You just got through Tree Thinking 101. We're going to end things off by addressing some common misconceptions. Misconception number 1, tips beside each other are more related than tips further apart. Wrong. The order of the tips do not show relatedness. Topology does. It is important to remember to not read across the tips. As an example, let's look at this tree. The blue circle is more closely related to the red heart than it is to the green triangle, even though the circle and the triangle are right next to each other. This is because the circle and the heart share a more recent common ancestor. Again, do not read across the tips. Misconception number 2. Looking at this phylogram, the yellow star is the ancestor and the green triangle is the most recently evolved species. Wrong! In the phylogram tree, the root is the ancestor and the tips are the evolved species. Read from root to tip to determine the time of divergence in a phylogram. Let's try another example. Looking at this tree, the swirl is more evolved and advanced than the smiley face. Wrong! Nodes simply indicate the number of common ancestor. They do not indicate levels of advancement or show primitiveness. Remember, evolution occurs by means of natural selection, so the odds of survival are higher for organisms that have traits that work for them in that specific environment at that specific time. A trait that led to survival previously may not do so now, and a trait that leads to survival now may not later. Advancement and primitiveness are concepts that are irrelevant to tree thinking. Misconception number 3. Looking at this tree, the outgroup, in this case S, undergoes no evolutionary change. Wrong! Outgroups are less closely related to other taxa in the tree. Outgroups are meant to show the bigger picture of evolution. Their evolutionary changes exist, but aren't shown in the specific tree because they do not fit in with the characteristics of that tree. One more to go. Misconception number 4. Species that arise from nodes are hybrids of their ancestors. So, for example, in this tree, the circle is a hybrid of the flower, the X, and the diamond. Wrong! Again, species evolve based on natural selection, which is non-random differences in survival and/or reproduction among individuals on the basis of heritable traits. New species are not a combination of ancestors. Congratulations! You now know the basics of evolutionary trees and the common misconceptions associated with them. Good job! Looking for more? Check out some of our resources used for this video for more in-depth material.